Alrighty, so let's get started with the demystifying these programming languages. So this course or this particular video is not going to be so much as creating our code. There are many ways to create code, and I'll explain some of those differences all based on different developers, though there is a common standard now in the professional world. First, we're going to be using JavaScript, which I'm not going to go into the full reason why it's an HTML file, other than the fact that JavaScript runs inside of pages, and pages are HTML. Now, they don't have to be, because you can also make your own JavaScript file. But for this purpose, I'm making it as simple as possible just to have the code visible and running for show and for comparison between the two or three. And of course, we're going to have a little bit of Python just to get experience looking at different languages. What I've found that when you're looking at multiple languages, especially in the beginning, you're able to kind of grab a concept that's a little bit struggling when you're trying to learn it in a school environment. Because when you're in a school environment, you're essentially focused on one thing, and it's almost a zealous way for you to learn the language through the class and the tests and all the stuff they push through to you. However, you don't think twice about what you're doing and how you're doing it. And for the matter of fact, you don't even compare it to anything else to really start to see how the concept of programming actually works. Not the language specifically, because all languages have a little bit of a different grammar if we're thinking of it as a spoken language. They have different grammars, but still in the end, in a spoken language, you can be Spanish, English, Chinese. You're still creating a sentence. You're still creating a communication factor. Just different languages, right? Different grammar and structure. But the wording and the concept of what you're trying to say is the same. This is exactly how these particular three languages, and many, if not all of them, work in harmony with the concept. And that's what we're focusing here, is the concept, not the language. But this will give you a better perspective on how they compare, and maybe even give you a little motivation to seek the one that's more appealing to you. So let's start off with our old friend C++. So this would be one of the very low level languages, described as a hardware level language, because in the end, we are just writing human readable words, or as close to human readable as possible. And sometimes we don't even have to write words to describe what we are creating. We can just write random characters. In fact, all of these that you see, some decimal, some integer, a letter, a sentence, these aren't any programming specific words. These are my choice of variables to be specific about what they hold. And you'll see that happening in the other languages as well. So you have full control over how you name your particular variables. Now, what is a variable? Let's start with that, right? A variable you can consider as a box. That's it, a box. And what does a box do? It holds stuff, right? So depending on the size of the box, which is very important in C++, it can carry a certain amount of stuff, or in our cases, numbers, strings, characters, integers, etc., floats. We got to be very specific when we're in C++ and we're talking about numbers, because they come in many flavors, simply because the length and the details, signs, plus, minus, all of those affect the size of the variable itself in memory. So this is how we consider this a hardware level language. We are creating a variable, and it is being stored directly on your RAM card or on your cache for your processor, depending on the running process. But most of the case scenario is it's going to be in RAM, and RAM has a specific layout and index of a bunch of numbers where it stores different parts or pieces of information like this variable. So as we're approaching this condition, this idea that a variable is directly represented inside of RAM, we have to be very diligent about what numbers, what values, what variable types we are using, and even how many decimals I put at the end of this, because if I put too many, it will end up essentially causing issues. There's only a certain size available, and you can also find those out if you search online for C++ variable sizes. That's when you're dealing with C++. This is one of the most hated things about C++, and honestly, I agree. But this is also the power of C++. It really is based on an intention of what you want your program to achieve. Sometimes you can do it directly on a simpler language like JavaScript or Python. Or sometimes you need to actually access the hardware layer to actually achieve something like a driver for a graphics card or a webcam or an operating system. Being able to also use the C++ language directly with the hardware does actually speed up the program that you create. The program runs much faster in this situation versus Chrome as HTML and JavaScript run, and versus Python. All of those are running on top of other software, while C++ is running on top of hardware, direct access to that hardware. And that's an important concept to remember, and also an important concept to attach to why all of this is so complicated. This shouldn't be a reason to really be demotivated because so many languages exist and you can achieve a lot of different things or goals or programs or whatever your ideas are in a much simpler language. But because this is kind of the introduction many students go through in college level, high school level, in university level, this is kind of what we learn, and we basically learn how to make a POS and how to add numbers and blah 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 blah, but that's not really the fun part. The fun part is when you start creating something more feasible. So let's continue. Well, what is all this stuff that I highlighted? In fact, let's be a little more direct. We have all of this code. Notice the alignment with the tabs. There is a tab for each line, about a single tab for each. Now, you don't necessarily have to do this in C++, but note for the future, you will have to do this in Python. You don't have to do this in C++ because it actually tells, or it knows where our code block begins with this curly brace here and where it ends with the other curly brace here. So we can kind of organize it visually just to make it nicer for us, and we can make these tabs here no, these are tabs. Tab, 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 tab. I'm not going to redo it. So all of these are tabs. This one's a tab, that's a tab, that's a tab, all of these. But the case is, you don't actually have to. It's not going to break your program if you don't. It's just going to make it very messy. And if you share your program with somebody, they'll probably cry and never look at your code again. Now, further, we have to consider the bigger picture here. Not the tabs, but the code block. This is a concept that exists throughout languages, all represented differently. But the concept here is that we want to organize our code in blocks. Blocks we can consider to be something related to these curly braces. In this case, it's a function, which we'll go into in a little bit, but many other situations arise with these blocks, these curly braces, for loops, while loops, if loops, all of the control type of functionality between different languages. For this quick video, I'm not really going to go through all the details of the control structure because we're still just scratching the surface of the complexity of C++, so I don't think you want to go into any further complexity. But if you do want to go into more detail and compare these three languages again with those control structures, please leave a comment underneath, a like and subscribe, and I'll be sure to make that as soon as possible. Now, further in, we will see code blocks vary in different sizes. This one is a single line code block. Very simple, very, well, not simple if you look at it from brand new eyes, but it's a single line, so it achieves what it does with a simple single line of code. This has multiple lines. So whenever we associate a particular type of process, like let's say adding, subtracting, those are all two different categories. Maybe we want to do exponential, maybe create a user interface where it asks the user for their name. You want to kind of organize those different categories into their own code blocks. That helps you go through your code later, not spend an extra 10 hours trying to figure out what happened when your computer program doesn't, well, compile. But you'll be able to go through and be able to track down each individual piece when you need to. Of course, you do have also error messages at the bottom. Now, I want to point out one particular thing that I personally don't like, which is understandable for the C++ environment, is the fact that when we're talking about strings, which is essentially a string of characters that are not registered as anything relating to the program, so our compiler, our code blocks, will ignore any sort of code-based parsing and just print it as it is. And in this case, we just consider it more of a human spoken language. This is where we can actually communicate and give messages to the user and even begin to speak to the user in many different places. And all of those are always a string, always, yeah, a little bit character here. Let me explain that. We have two quotes to create this string. Now, I want to be specific. I'm going to go to character in a second. What does this actually look like as a weird character? Because we kind of see a little bit here. A character is a single character, a single letter. So how can a character be multiple letters in one? Well, it's the magic of these brackets here. This creates an array. This array holds each letter independently next to each other. So you would have a situation where you're looking at this. And I'm probably not going to go through all of them, even the space. Keep that in mind. And I think you possibly get the idea. Now, the idea further is that this array is essentially our sentence, our string. Now, when we actually throw it through, the program or our code blocks plus the compiling process will treat it as a string simply because of this connotation. There is ways to use strings as well and create a string sentence equals to the quick brown box. But in order for us to use this string type, it's not local to our code blocks, or it's not local to our file right now. Notice at the very top, we have the ability to include extra what we call libraries, or in some cases, if you're working with HTML, JavaScript, Python frameworks and APIs and all that kind of stuff, basically all those complex words just mean code that we're importing that somebody else has created. So IOStream is input output stream. That's particularly what it means. And what that means is essentially input and output. The things that into the computer go into the computer, and the things that output to the computer. What it really does is it creates and lets us access the buffer, a buffer that is basically going to keep information, consider like a temporary file, a buffer, and it's going to basically attach, and this is really where it's coming from here. We're going to attach this particular hello world from C++, and we're going to attach it to the cout, basically computer out, if you want to consider it this way, which means that we're going to be printing it to a screen or to a terminal when we run the program. And in that case, we're sandwiching this with a end line so that we can actually stop it from continuing indefinitely. We want to make sure we tell it when to stop because C++ is that touchy. But when we do print, we have to include an external library, and there's many libraries to go for. In fact, when we go through any of these courses and classes and sessions and videos, whatever you want to call them, you're essentially really focused on learning what is happening down here. That is essentially primary parts that you need to learn. Any developer that's beginning to learn a language needs to really focus on those, because in the end, when you take a peek up here and consider that this is something that we can add on, well, this is one of thousands of things we can add on. That's the other 85% of programming. So when you focus up here, you're essentially comfortable with programming in a general sense. So our focus is going to be the 15%, and we're going to go through all the concepts relating to that particular 15. Further down the road, I may introduce some interesting libraries, and we can even make our own libraries. I'm running the program. We're having some issues. Let me see. Okay, good. Oh, I think I deleted. Right. There's another one. Actually, a very good situation here that we got an error. C++ is very, very, very touchy. Bugs will bug you in your sleep. If you are taking this class in college, notice that the smallest mistakes, human errors, will cause you hours of pain because you won't be able to see it simply because you've made that mistake by not even including it in the first place. It's like saying, how do you know what you don't know? In this case, the error tells me, hey, I expected a semicolon, but I don't see it, right? Before car, car is on the next line, so that's weird too. It's like, hey, I'm pointing out this location, but really my error was right here because I didn't put this semicolon there. So there's another little bit of a yay with C++. It's so much fun to play with. Now let's actually see the product and see if we can get motivated. And there it is, the program has run successfully. We see the hello world from C++ printing onto what we call our buffer. Well, our buffer was kind of the pre-situation to the print on the screen, but anything that gets printed to the buffer and shown here, which is essentially where the majority of college level projects last. We'll continue in the next video, where we will do this exact example, but in JavaScript.